Okay, and here we have our second example. Now the table below shows the student's initial attempts at investing. And we can see, okay, here are the years since investment and the value of stock in dollars. Now what I would encourage you to do is I would encourage you to take a photo, and of course what we're going to do is we're going to go back to the Desmos graphing calculator. So once again, you can write that down, Desmos graphing calculator, Google it, but let's go to that website. And what we're going to try and do is find the function that best models the data above. Okay, so here we are over at desmos.com/calculator. Now remember, the first thing we want to do, click add item, and we want to go down and we want to click this table. And it gives us these two columns, x1 and y1. Now if you remember, on our left column it's going to go down 0, 1, 2, 3, 4, and 5. That's pretty easy. But let's go look at our right column. What are going to be our output values? Okay, so I'm pulling up this table. Remember, you should have taken a photo of it. And so we're going to have 380, 395, 411, 427, 445, and lastly 462. Now from here, remember, you click here, and all we have to do to be able to analyze this table is we're going to write y and then some form of a parent function. So for instance, you're going to push the tilde button, and so if you look in the top left corner of your keyboard, right under the escape button, you should do shift and then that squiggly line, that's called a tilde. And let's go ahead and do just an X. So if you'll recall, that's going to be, oh, how do we run this regression? Oh yeah. And then the last thing, remember, I forgot, it should be y1 and of course x1. And then we'll click that. And you know what? The one thing I'm forgetting is it should be as a parent function mx plus b. Okay, now if you'll notice, how can we look at this function y tilde mx plus b, remember y1 x1, and we see that the r squared value is 0.999. So that's pretty good. Like if we have a 0.999, that's very close to 1, but it might not exactly be the best. So let's try a different one. Let's say, what if we tried this? What if we tried a quadratic? So we're going to push X, and I'm going to hold down the shift button and push 6, which is the little arrow pointing up. And we could put that, and actually we want to put the standard form. So ax squared plus bx plus c. And what am I missing? Well, of course, that has to be an x1, and that also has to be an x1. Oh, now this is really good, 0.9999. Okay, so that one looks pretty good. And so this is probably going to be a quadratic regression, but let's try one more. So that's for quadratics. And our only other option is we want to try out a regression. So I'll put b to the power of x, and let's see. Oh, remember, what am I forgetting? x1. And this really doesn't match up too well. What if I put an a right there? Well, that, aha, there we go. So notice this is 0.999, and we actually kind of have a tie. Like, it seems like this could be both modeled well by a regression or by an exponential. Well, let's go ahead and choose an exponential function for this one, just because I'm going to do a quadratic for our next one. But just understand that these points are just kind of weirdly unique, and that we could have used one or both. Now, what's our next step? I want to write down this a value and this b value. So we're going to write down a equals 379.92, and I'm going to write down b equals 1.04. And once I have those two numbers right there, a and b, which come from this equation, we can go on back to our original panel and finish out the problem. Okay, so now we're back to example 2. And remember, we had decided what we were going to do is we were going to go ahead and use the exponential form, which we can write as y equals, and let's go ahead and write that as a b to the x. And so I'm sorry if there is any confusion as I was kind of going through those examples. We really want to use this form of an exponential. It's the general form. Now remember, we also wrote down our A value, and so my A value was 379.92, and my B value was going to be 1.04. Okay, so what's that going to look like when we plug it into this equation? Well, we could write y, or I could even switch it up. I could write f of x, which I think is how I kind of give these to you in the problem. F of x is equal to, and see how a comes first, so I write 379.92, and then our b values here inside this parentheses, 1.04, and then we're going to raise that up to the power of x. And this has answered letter A. What is the function that models this? Now, there is our answer to A, but what about B? It says, how much money would the student have at the end of 25 years? Well, what we can do is we can assume that they're kind of just investing that and it's growing at this rate constantly. So we're going to write this as f of, and our input is going to be 25, is equal to, we'll go ahead and write our A value. So 379.92, and then 1.04 raised up to the 25th power. Now this is something that you're going to have to use an online calculator for. And let me go ahead and use my calculator here, because I was able to take one of the nice fancy ones from the school. Okay. So just typing it all up, raising up to the 25th power, it looks like after 25 years, our student would have $487.22. Now, just in case you're wondering, is this a good investment strategy for you to start with $380 and then 25 years later you'd only have $487? So you gained $107 over a 25-year period? No, that would be a terrible investment. In fact, that would be kind of you keeping this in a savings account and it growing at a very slow rate over all that time. All right, let's go ahead and move on to our third and final example for this assignment.